Our project is on derivatives. The definition of a derivative is the slope of a line tangent to a function. So if this is our function and this is our tangent line, the equation that we find is going to be the slope of this tangent line at this specific point. We are going to find the derivative of f of x equals x to the third over x to the fourth plus 9x plus secant to the fifth of 7x squared plus 12. This example is an equation using the quotient rule and the chain rule combined with a trigonometric function. Here is just the quotient rule, the chain rule, and the derivative of secant of u, which is the trigonometric function that we are going to be using for this problem. Here is the original equation that I already said, and here it's just slightly rearranged. We just took the 5 from after the secant and moved it to the outside here. Here is the derivative, and we ran out of space, so we kind of had to split it over 2 lines, and we had to split the trigonometric function, which I'll show you later. This is 3x squared times x to the fourth plus 9x minus x to the third times 4x to the third plus 9 over x to the fourth plus 9x squared. And this expresses the quotient rule, which is f prime of x times g of x minus f of x times g prime of x over g of x squared. And then we have plus the chain rule times the derivative of secant of x. The chain rule, we end up with 14x, which is the derivative of the inside, times 5 secant to the fourth, which is the derivative of the outside. Plus we have to take the derivative of secant of x, which is here. You end up with a secant of 7x squared plus 12 times tangent of 7x squared plus 12. Here we just multiplied everything out, so we got 3x to the sixth plus 27x to the third minus 4x to the sixth minus 9x to the third over x to the eighth plus 18x to the fifth plus 81x squared plus 70x times secant to the fifth of 7x squared plus 12 times tangent of 7x squared plus 12. You end up with a secant to the fifth because of the secant to the fourth being multiplied by the secant tangent. The secant times secant to the fourth gives you the secant to the fifth. Here we just combined like terms, ended up with a negative x to the sixth plus 18x to the third in the numerator, and everything else stays the same here. Here we just simplified a little bit and pulled out an x squared and ended up canceling out the x squareds on both the numerator and the denominator, and here's the final equation, which is negative x to the fourth plus 18x over x to the sixth plus 18x to the third plus 81 plus 70x secant to the fifth of 7x squared plus 12 tangent of 7x squared plus 12. So I hope that was helpful for the quotient rule, the chain rule, and the derivative of a trigonometric function.